Yesterday we looked at trig identities and proving those, and that's a proof where we're trying to show it's true for all values. Trig equations, of course, we're just trying to find it's true for which values. Let's just look at a handful of them. Tan theta is negative 2.3673, and I guess the first question we ask ourselves is, hang on, how far do we want to look for solutions? Because of course there's an infinite number of solutions. So usually they will tell us, hang on, just look for answers between these values. The standard one is 0 and 360, but it doesn't have to be. It could be any range of answers that they could be asking for. Then we would want to go and work out, well, which quadrants are we in? Obviously this one, tan's negative. Okay, I know I'm in the second and the fourth quadrant. We then have to find the equivalent acute angle, because of course our calculator likes nice acute angles and it won't tell us both answers. So the equivalent acute angle, I just make it positive, of course, and that's what I'm trying to find. For this one, 67 degrees 6 minutes. Now I want to go and solve the problem, pull it all together. What are we saying? It's in the second quadrant and it's in the fourth quadrant. The acute angle is that one there. So all right, the answers I'm looking for is 180 minus that acute angle and 360 minus that acute angle. Substituting, we get the answer. Now of course, you probably don't write every one of those lines down, but that's the thought process we're going through when we solve these equations. Cos theta equals a half. Again, I'm going between 0 and 360. All right, I'm in the first and the fourth quadrants. My acute angle would be 60 degrees. That's the first quadrant, and 360 minus alpha for the fourth quadrant. I get my two answers. So we've seen these sorts of ones. Cosec though, that's a little bit different. We don't have a cosec button on our calculator, of course. I guess the first thing we do is turn it into something our calculator will handle. So I'll change it to a sine ratio. Sine is a quarter. In the first and the second quadrant, the acute angle is 14 degrees 29. We have our two answers. Hang on a sec. It's an equation like any other. We want to make x the subject, but of course before we can make x the subject, in this case we've got to make the trig piece the subject. So we make sine x the subject. Negative a half. Okay, third and fourth quadrants. The acute angle is 30 degrees. Put it all together. Got my two answers. I've got two different trig ones. So now this is where knowing our relationships and identities come in handy, because I could rewrite this one as sine divided by cos, which is of course tan, and I get a simple little trig equation to solve. I'm in the second and the fourth quadrants this time. Find the acute angle, pull it all together. Once again, I get two answers. Hang on, 2 theta. This is where we have to start really being careful. If they're asking for cos 2 theta, remember, I'm looking for answers for theta between 0 and 360. So therefore, 2 theta, I'm looking for answers between 0 and 720. First and fourth quadrant, find the acute angle, so it's still all the same. Pull it together, but I got to go around the circle twice. So once I find the two standard answers that I would have had, I just add 360 to both of them. So I've gone around the circle, I've got all four. Now I'll divide by 2 and I can get my answers for theta. So I've got 4 answers in this case. Sec squared plus tan, alright, but we have a trig identity that will handle that. Sec squared is of course 1 plus tan squared. We have a quadratic equation. What multiplies together to give negative 2 adds together to give 1? Yeah, I can do that. I now have two different trig equations to look at. First one, tan theta is negative 2, second and the fourth quadrant, acute angle. Okay, I've got those two answers. My other one, tan theta equals 1. Well, that's a bit nicer because that's one of our exact values, isn't it? 45 degrees. Pull it together. Don't leave your answer like that. Write a final solution. Here are all the 4 solutions. Don't say, look, I've got 2 of them over here and 2 of them over here. No, a nice one. And I'd like to put them in order. I suppose they don't have to be in order, but it's kind of logical to write them in order. Okay. So 6H, but I've also thrown some questions in there from the old Cambridge textbook, which should be in the back of the handout there. Copied that in to have a look at as well.